Welcome back to our channel, Universe Intelligence. Today, we unravel the mystery of the Collatz Conjecture. What's something people don't know about the Collatz Conjecture? It's a real head-scratcher in math, puzzling even the greatest minds. It's called the Collatz Conjecture, and it's one of those problems that seems simple at first glance but hides a deep complexity. This enigma has stumped mathematicians for almost 100 years. Imagine that, a century of brilliant minds trying to crack this puzzle. The beauty of the Collatz Conjecture lies in its simplicity. It's easy to understand but incredibly hard to solve. This paradox shows just how mysterious and intriguing numbers can be. They hold secrets that are not always easy to uncover. So here's the deal. Pick any whole number, any number at all. If it's even, you simply divide it by 2. Easy, right? If it's odd, you multiply it by 3 and then add 1. Simple steps, but they lead to fascinating results. Keep doing this with the new number you get, repeating the process over and over. The Collatz Conjecture claims that no matter what number you start with, you'll always end up at 1. It's a bold statement. What's so cool about this is how easy the rules are. Anyone can follow them, even if you're not a math whiz. This means that anyone can get involved and try it out, making it a fun challenge for everyone. But here's the catch. Proving that it works for every single number is a whole different story. This is where the real challenge lies. Mathematicians have been trying to prove it for decades, and it's still an open question. It's like a brain teaser that everyone wants to crack. The Collatz Conjecture continues to be a tantalizing mystery in the world of mathematics, inviting both amateurs and experts to take a shot at solving it. This puzzle is named after Lothar Collatz, a German mathematician who came up with it back in 1937. He was fascinated by how numbers behave and relate to each other. He noticed this weird pattern when playing around with this simple math trick. Even though it seemed simple, Collatz couldn't prove it always worked. He told his friends, and soon everyone was talking about it. Mathematicians everywhere wanted to solve this puzzle. What makes this puzzle so important is that it connects to really basic ideas about numbers, like how they divide and how sequences work. Figuring out the Collatz Conjecture would be a big deal for understanding how numbers work. It looks simple, but it's actually a really deep math problem. Even after all these years, nobody has cracked the Collatz Conjecture. This mathematical puzzle has intrigued and baffled mathematicians for decades. Despite numerous attempts and countless hours of research, the solution remains elusive. No one can prove for sure that every number eventually leads to 1. The conjecture states that if you take any positive integer, follow a simple set of rules, and repeat the process, you will always end up at 1. But proving this for every possible number is a monumental task. We've tried using computers to test loads of numbers and it seems to work, but that's not a real proof. Computers can handle vast amounts of data and perform calculations at incredible speeds, but they can only test a finite number of cases. A true proof needs to work for all numbers, no matter how large. One way to look at it is with a spreadsheet. By inputting the rules of the Collatz Conjecture into a spreadsheet, you can observe the behavior of different numbers. This method allows for a visual representation of the process, making it easier to spot patterns and anomalies. You can put the rules into the spreadsheet and see what happens with different numbers. As you enter various integers, the spreadsheet calculates the sequence of operations, showing how each number transforms step by step. It shows you how the numbers go up and down, but always seem to land back at 1. The visual fluctuations can be quite dramatic, with some numbers taking many steps to reach 1, while others do so quickly. This graphical approach helps to illustrate the unpredictable yet consistent nature of the conjecture. You can also use computer programs to make pictures that show how the Collatz Conjecture works. These visualizations can range from simple line graphs to complex fractals, each providing a unique perspective on the problem. You can see how different starting numbers take different paths, some long and some short, but they all seem to end up at 1. These pathways can be mapped out in flowcharts or diagrams, highlighting the diverse journeys numbers take under the Collatz rules. These tries have helped us understand the puzzle better, but we still don't have a complete answer. Collaborative efforts and innovative approaches continue to push the boundaries of our understanding, yet the ultimate proof remains just out of reach. The Collatz Conjecture stands as a testament to the enduring mystery and beauty of mathematics. Computers are perfect for exploring the Collatz Conjecture. They can test millions of numbers and create pictures that help us see how it all works. A simple computer program can show the Collatz conjecture in action. It can run the rules on lots of numbers and show you the sequences. You can see how the numbers jump around, but always seem to land back on one. Another way is to use a special program that makes pictures from data. You can create cool visuals that show the paths that numbers take with the Collatz process. These computer experiments have helped us learn a lot about the puzzle, and even find new patterns we wouldn't have seen otherwise. We usually think about the Collatz conjecture with regular numbers, like the integers we use every day for counting and basic arithmetic. These are the numbers we are most familiar with, and they form the foundation of many mathematical concepts. But what if we step outside this comfort zone? We can try applying the Collatz conjecture to other kinds of numbers too. This isn't just a theoretical exercise. It can lead to fascinating discoveries and insights. This opens up a whole new world of possibilities. Imagine the vast expanse of the universe, each star representing a different type of number we could explore. The potential is limitless. Imagine trying it with complex numbers. These numbers, which include a real part and an imaginary part, are used in many advanced fields of science and engineering. These numbers have a special part called I, which stands for the imaginary unit. The imaginary unit is a fascinating concept that extends our number system beyond the real numbers. And when you use them with the Collatz conjecture, you enter a realm of mathematical beauty and complexity. The results can be both surprising and mesmerizing. You get these amazing fractal patterns. Fractals are intricate, never-ending patterns that are self-similar across different scales. They are a visual representation of the complexity hidden within simple rules. They're super intricate and show just how complex this simple puzzle can be. The beauty of fractals lies in their infinite detail, revealing more layers the closer you look. Another way to look at it is by writing the numbers in binary code, which is just ones and zeros. Binary code is the language of computers and digital systems. This can reveal hidden shortcuts and patterns in the Collatz sequences. By examining the sequences in binary, we can uncover new relationships and properties that are not immediately obvious in decimal form. These different ways of looking at the Collatz conjecture allow us to see the problem from multiple perspectives. Each perspective can offer unique insights and solutions. These different ways of looking at the Collatz conjecture show just how many connections it has to other parts of math. The Collatz conjecture is not just an isolated puzzle. It is deeply intertwined with various mathematical disciplines, highlighting the interconnectedness of mathematical concepts. Believe it or not, the Collatz conjecture can even be turned into music. We can take the number sequences and turn them into notes. The ups and downs of the numbers become the melody. The music you get is often really surprising and beautiful. It's like the puzzle has a hidden harmony. This musical side of the Collatz conjecture shows how beautiful math can be. It's not just about equations. It can inspire art too. The Collatz conjecture is a simple puzzle with a big mystery at its heart. It shows us that even in math, there are still things we don't understand. What's so cool about it is that anyone can understand the rules, but no one has solved it yet. That's what makes it so interesting. Trying to solve the Collatz conjecture is like exploring uncharted territory. It's a quest to understand the secrets of numbers and patterns. It reminds us that there's still so much to discover in math. The Collatz conjecture is a beautiful and mysterious puzzle. It challenges us and reminds us that even when things seem impossible, the search for knowledge is always worth it. Why did the mathematicians subscribe to our channel? Because he couldn't resist the prime content. Hey, don't forget to hit that subscribe button.